Okay, so AI, it's everywhere, right?
Hmm.
But it needs some serious hardware to keep getting smarter. Like, imagine if the brains behind AI were limited by, I don't know, like old tech. That's kind of where AlphaChip comes in.
Yeah, and that's a really big deal because the progress of AI really relies on having these powerful chips to support it, and designing those chips is incredibly complex.
Oh, it's super complex. And we're talking about DeepMind here, the folks who made AlphaGo.
Yeah.
But this time, they're not playing games, they're designing chips. Well, not the actual chips, but the like blueprints for chips. Those are called chip layouts, right?
Exactly, and these chip layouts basically determine how everything's arranged on those tiny, powerful devices, the placement of every single component.
How fast it can go, how much power it uses, the whole thing, right?
Absolutely, and here's the kicker. AlphaChip can design these layouts incredibly fast. We're talking hours compared to the weeks or even months it would take human experts.
Yeah, I read that too. It's insane. But this isn't just theory, right? This is actually happening. AlphaChip's already designing Google's TPUs, those super fast AI chips we hear about all the time.
Right, and it's not just Google. AlphaChip's also being used by MediaTek.
MediaTek, I know that name. Aren't they like a major chip maker?
They are a huge one, actually. They make chips for a lot of things, including smartphones. In fact, MediaTek used AlphaChip to design the layouts for their Dimensity 5G chips.
And those are in like actual phones that people are using right now.
They are. Samsung phones, for example, use those chips. So AlphaChip's impact is already out in the real world.
Okay, so I got to ask a dumb question here, maybe.
Yeah.
I get that chips are complex, but can we break it down? Like, what is a chip layout? What are we actually talking about here?
Sure. So think of a chip as like a tiny, super dense city. And each building in this city is a transistor, which is like a microscopic switch that controls the flow of electricity.
Yep.
Billions of them, all packed together.
Billions. Wow.
Billions, yeah. So the chip layout is essentially the city plan. It determines where every single one of those transistors goes, how they're connected, how the whole thing is organized.
So, like, it's high-stakes Tetris with billions of pieces, trying to fit it all together perfectly.
It's a pretty good analogy, actually. And the way these components are arranged, it affects literally everything. How fast the chip can run, how much power it uses, how much it costs to manufacture, the whole deal.
And before AlphaChip and AI doing this, this was all done by hand.
Largely, yes. It was incredibly painstaking work, a huge bottleneck in the whole process. I remember reading in one of the articles we looked at, they were saying that the number of possible combinations for arranging components on a chip, it's something like the number of atoms in the universe.
Yeah, I remember that. Absolutely insane. So that's why using AI for this is such a big deal, right?
Absolutely. It's like having a superpowered assistant that can sift through all those possibilities in the blink of an eye and find the best solutions. Solutions that we, as humans, might never even think of.
And I read about the type of AI that AlphaChip uses. It's called reinforcement learning, right?
That's right. It's the same kind of AI that DeepMind used to create AlphaGo, the AI that beat the world champion Go player.
Hold on. So it's like AlphaChip is playing a game, but instead of Go, the game is design the best chip layout.
You got it. It tries different arrangements, gets feedback on how well they work, and learns from its mistakes. Over time, it gets better and better at designing these incredibly efficient layouts.
So it's like trial and error, but at super speed with like a super smart computer brain doing it.
Pretty much. And it gets smarter with every attempt.
I also read that it uses these things called graph neural networks. What even is that? It sounds complicated.
It is complicated, but essentially it's how AlphaChip understands the relationships between all those components on the chip. It's not just placing things randomly, it's learning which parts need to be close together, which can be further apart to make everything run smoothly.
So like it could see the whole picture,
Hmm.
not just individual pieces.
Exactly. It's looking at the entire chip as a complex system and understanding how all the parts interact with each other.
So it gets the big picture. That's pretty amazing.
Yeah.
And it's actually leading to real results, right? Like
Well,
those TPUs we talked about, those are outperforming human designs.
They are, and by a significant margin. And it's not a one-time thing. With each new generation, AlphaChip is getting better and better, and those TPUs are getting even more powerful.
That's really impressive. And going back to that MediaTek thing, that really hits home how impactful this is. Using AlphaChip to design chips for smartphones, that's huge.
Absolutely. It shows that AlphaChip isn't just a research project, it's a real-world tool that's already having a significant impact on the tech we use every day.
Yeah, that's kind of mind-blowing. But I got to be honest, when I was reading up on this, I did see some articles where people weren't totally sold on AlphaChip. Like, they were a bit skeptical.
Oh, yeah, there's definitely some healthy skepticism out there.
So what are their concerns? Like, what are they not buying?
Well, some people are asking for more transparency. Like, Google did release a pre-trained version of AlphaChip, which is a good step. But some researchers, like Igor Markov and Patrick Madden, they want to see it tested on, like, public benchmarks, the standardized tests for chip design.
So they want to make sure it can really walk the walk,
Yeah,
that it's as good as Google says it is.
exactly. They want to see independent verification, basically. And I think that's fair.
It makes sense. They want to see the receipts, basically. Okay, so let's pause here for a second and zoom out a bit. All this talk about chip layouts and AI design, it's fascinating. But what does this actually mean for everyday people? Like, why should we care?
That's a great question. And the answer is, well, it affects pretty much everything. Think about it. Chips are in everything. Our phones, our laptops, our cars, even our refrigerators these days.
Okay, true. They're everywhere. But what does AlphaChip change about that?
It means those chips can be faster, more efficient, and more powerful. And that translates to faster phones, longer battery life, smarter devices.
And I'm guessing cheaper too. If it's faster to design these chips, maybe that means they cost less to make.
It could, yeah. And that could make technology more accessible to more people around the world.
Okay, so there's that.
Yeah.
But it sounds like there's even more to it than just faster phones and cheaper gadgets.
There is. It goes deeper than that. AlphaChip could actually change the way chips are designed. Traditionally, only huge companies with tons of resources could really do this kind of cutting-edge chip design.
Because it was so expensive and time-consuming.
Exactly. But AlphaChip has the potential to democratize chip design, to make it accessible to smaller companies, even startups.
So we could see more innovation, more new ideas coming from all sorts of places.
That's the exciting part. It could lead to a whole wave of new technologies and applications that we haven't even thought of yet.
Wow, okay, this is getting kind of mind-blowing. So it's like AI is both pushing chip development forward and being used to design even better chips. It's what do you call it, a feedback loop?
Exactly. And that loop is only going to accelerate in the coming years. There's so much more to explore with AI and chip design. Like, it's not just about AlphaChip and those layouts. AI is starting to play a role in pretty much every stage of the design process.
Okay, so AlphaChip is like the poster child. But there's a whole world of AI-driven design happening behind the scenes.
Exactly. There's a lot going on. And some of it's even more mind-blowing than AlphaChip, if you can believe it.
Okay, now you got me hooked.
Yeah.
What else is going on? What kind of things is AI being used for in chip design?
Well, last time we mainly talked about AlphaChip's specialty, right, which is macro placement, deciding where to put the big blocks of circuitry.
Right, like the CPU and memory, all those major components?
Exactly. But AI is also being used for other stages of design, like logic synthesis, for example.
Okay, I need a refresher. Logic
Okay.
synthesis, that's
So basically, it's taking the high-level design of a chip, like what it's supposed to do, its functions, and translating that into a network of logic gates. Think of it like you have an architect's vision for a building, and then you need to create detailed blueprints that the construction workers can actually use.
Okay, yeah, I see. Translating the concept into the actual nuts and bolts. And this is traditionally a really complicated process, right?
Oh, super complicated, yeah, and very time-consuming. Traditionally, it involved a lot of manual work from, really skilled engineers.
So how is AI changing that? Is it replacing engineers entirely, taking over their jobs?
Not quite replacing, no. I think it's better to think of it as giving them a superpowered assistant.
Okay, I like that. So a super smart AI sidekick. What does this sidekick actually do, though?
So these AI algorithms can analyze chip design, the whole thing, and they can figure out the most efficient way to connect all those logic gates. They can explore thousands, even millions of different possibilities and find the best solutions. Solutions that use the least amount of power, take up the least space, and still meet all the performance requirements. Stuff that would take human engineers forever to figure out.
So it's crunching all the numbers and doing all the tedious work so the engineers can focus on the bigger picture.
Yeah, exactly. It's like having an AI co-pilot that's sifting through mountains of data, testing different options, and then presenting the best ones to the engineer. It can dramatically speed up the design process.
That's amazing. So that's logic synthesis. What else is happening?
Well, there's also macro selection. Remember we talked about macro placement, where you decide where to put the big blocks of circuitry?
Yeah.
Well, before you can place them, you have to actually choose the right ones. Which CPU, which memory modules, things like that.
Right. It's you need to decide what kind of buildings you want in your city. before you start figuring out where to put them on the map.
Exactly. And that can be a tough decision because there are usually lots of different options, each with its own, like, pros and cons.
I'm guessing this is where the AI comes in.
It is. These AI algorithms can be trained on huge databases of chip designs and performance data. So they learn what works well, what doesn't, and they can use that knowledge to make recommendations.
So it's like they've studied all the best practices, and
Well,
they can say, hey, for this particular chip design, these are the components that will give you the best results.
that's the idea. It's like having an AI consultant for chip design.
That's pretty awesome. So we've got logic synthesis, we've got macro selection. Anything else?
Oh, yeah, we haven't even talked about timing optimization yet.
Timing optimization. Refresh my memory.
So this is all about making sure that signals are traveling through the chip at the right speed, everything's synchronized. Imagine a city where all the traffic lights are out of sync. It'd be chaos, right?
Yeah, total gridlock.
Same thing in a chip. If
Ah.
those signals aren't timed correctly, it slows everything down, things don't work properly, and the whole chip can basically fail.
Gotcha. So how does AI help with that?
Well, it's a really complex problem involving like millions of transistors and wires all interacting. Traditionally, it was a very iterative process. Engineers would make adjustments, run simulations, see if it worked, and then repeat over and over again.
Sounds super tedious.
Oh, it is. But AI algorithms can analyze the entire design and identify those timing problems before they even happen. They can suggest modifications, tweaks to the layout, or even the circuitry to improve the timing and ensure that the chip performs as intended.
So it's like a superpowered debugger finding problems before they even exist.
That's a good way to put it.
Okay, so we've got AI streamlining logic synthesis, helping with macro selection, and optimizing timing. It sounds like it's becoming like indispensable for chip design.
It's definitely becoming a much bigger part of the process. And as these AI algorithms get better, and as we gather more and more data about chip designs and performance, well, AI is only going to become even more important.
That's super exciting, but I also have to wonder if there are any like potential downsides to relying so heavily on AI for something as important as chip design. Like, are there risks involved?
That's a great question, and it's one that the entire industry is thinking about right now. It's not all sunshine and roses. There are definitely challenges that come with this AI revolution.
So let's talk about that. What are some of those challenges? What should we be worried about?
I think one of the biggest ones is making sure that the AI algorithms themselves are reliable. Like, we're talking about designing the brains of the devices that, run our world. We need to be damn sure that those brains are working correctly.
Yeah, that makes sense. So how do we do that? How do we make sure these AI algorithms are up to snuff?
It's not easy. It's a multifaceted problem. But I think one key aspect is rigorous testing. Like, we need to put these algorithms through Winger, test them on every possible design, and compare their results to, what we get with traditional methods.
So it's like before you let someone fly a plane solo, you want to make sure they have enough hours in the simulator. Right?
Yeah.
Make sure they can handle anything.
Exactly. We need to train these AI algorithms and make sure they're ready for the real world. And another important piece is transparency. We need to be able to understand how these AI algorithms are making their decisions.
Okay, so it's not enough to just see that they're producing good results. We need to know why they're making the choices they're making.
Absolutely. If an AI algorithm comes up with a totally new chip design, something we've never seen before, we need to be able to trace back its logic. Like, why did it choose this component over that one? Why did it arrange things in this particular way?
So, like, we need to peek under the hood and understand how the magic is happening.
Right, and that's where explainable AI comes in. It's a whole field of research that's focused on making AI algorithms more transparent, more understandable.
So instead of just having a black box that spits out answers, we're working on ways to make those boxes like see-through so we can understand the process.
That's the goal. And it's going to be crucial as AI becomes more and more integrated into every aspect of chip design.
Okay, so we've talked about some of the amazing things AI is doing in chip design, and we've also acknowledged that there are some challenges and things to be cautious about. Where do we go from here? What's next on our AI chip adventure?
Well, in the final part of our deep dive, we're going to take a look at the really far out stuff, the mind-blowing possibilities that lie ahead. We're talking about things like co-optimization, where AI is used to design both the hardware and the software together, creating chips that are specifically tailored to run certain AI algorithms. It's like a whole new level of optimization.
Wow, okay. So AI designing chips that are specifically built to run AI algorithms. It's like the chips are designing themselves.
It's getting close to that, yeah. It's a really fascinating area of research, and it has the potential to unlock, like, incredible performance gains. And we'll also be talking about the possibility of AI designing chips that can actually design and optimize themselves. Chips that can think about their own design and improve over time.
Okay, now that's mind-blowing. I can't wait to hear more about that.
It's going to be wild. It's a glimpse into a future where the line between hardware and software starts to blur, and where the possibilities for AI-driven innovation seem almost limitless.
And I gotta say, my head is spinning a little bit. We've been through like a crash course in AI-powered chip design.
It's a lot to take in, for sure. We've covered a lot of ground.
We talked about AlphaChip and how it's like this master chip layout designer working way faster than humans ever could.
And we talked about how AI is being used for, pretty much every part of the design process now, not just layouts.
Yeah, it's like AI is becoming the ultimate chip design assistant,
Yeah.
streamlining everything, making things more efficient.
Exactly. And we also touched on, some of the things we need to be careful about, like making sure we can trust these AI systems, making sure they're doing things for the right reason.
Right, responsible AI and all that. But
Yeah.
you said the most mind-blowing stuff was still to come. I'm ready to be blown away.
Okay, well, hold on tight. Remember we talked about how AI could be used to design chips that are specifically tailored to run certain AI
Yeah,
algorithms?
to optimization, right?
That's it. And this is where things get really interesting. It's like, instead of just designing a general purpose chip that can do a bunch of different things, you're designing a chip that's laser focused on one specific task.
So like instead of a Swiss Army knife, it's more like a scalpel.
Perfect analogy. It's
Yeah.
all about specialization. Traditionally, chip designers would create a general purpose chip, and then software developers would come along and write their AI algorithms to run on that chip.
Right. It's like separate teams working on separate things.
Exactly. But with co-optimization, those teams work together. The hardware and the software are designed in tandem, each one informing the other. It's like a dance.
Okay, that makes sense. But can you give me a real world example? Like, how would this actually work in practice?
Sure. Let's say you're building a self-driving car. You need a chip that can handle all the data coming from the sensors, the cameras, the radar, everything.
Yeah, tons of data all coming in at once.
And it has to process that data in real time, make split-second decisions about steering and braking. It's a lot.
Definitely needs a powerful brain.
Right. So with co-optimization, you could use AI to design a chip that's specifically optimized for those tasks. Like, you could have specialized circuits for image recognition, for path planning, for all the things a self-driving car needs to do.
So it's like instead of a general purpose brain, it's a brain that's specifically wired for driving. Like it's got all the right connections already built in.
Exactly. And that kind of specialization can lead to huge gains in performance and efficiency. The chip can do its job faster, better, and using less power.
This is starting to click for me now. So it's not just some sci-fi concept. This is actually happening.
Oh yeah, it's happening. Think about Google's TPUs. Those chips are designed from the ground up to accelerate deep neural networks, which is a specific type of AI algorithm.
So Google's using AI to design chips that are specifically tailored to run the AI that powers like their search engine and all their other stuff.
Exactly. And it's giving them a huge advantage. They can run their AI faster, more efficiently, at a scale that no one else can match.
Wow. Okay. This co-optimization thing, it's a game changer. But what else can we do with it? What other possibilities are out there?
Well, think about personalized medicine. Imagine a chip that's specifically designed to analyze your DNA, identify potential health risks, or maybe even tailor treatments to your specific genetic makeup.
Okay, that's amazing. So instead of like one-size-fits-all healthcare, you could have chips that are designed just for you. Personalized healthcare on a chip.
Exactly. And this could be applied to all kinds of fields: finance, climate modeling, materials science. The possibilities are pretty much endless.
I'm starting to get a little dizzy here. So co-optimization is amazing. But where do we go from there? What's the next big leap?
Well, some researchers are already looking beyond co-optimization to something even more radical. They're talking about self-evolving chips.
Self-evolving. Hold on, you mean chips that can design and optimize themselves? Like they're alive?
Not alive, exactly. But the idea is that the chip is constantly monitoring its own performance, looking for ways to improve. And then it can actually make changes to its own design without any human intervention.
Whoa. So it's like the chip is thinking about its own design and figuring out how to make itself better.
That's the idea. It's like a brain that's constantly rewiring itself to become more efficient, more intelligent.
Okay, that's both fascinating and kind of terrifying. Is this, like, actually possible? Are there examples of this self-evolving chip thing happening yet?
It's still very early, but researchers are working on it. They're experimenting with chips that can, like, reconfigure themselves on the fly, adapt to different tasks. It's pretty wild stuff.
So it's like a chip that can change its shape depending on what you need it to do, like a transformer, but for chips.
Huh, kind of. And this opens up all sorts of possibilities. Like, imagine a chip in your phone that learns how you use it and then optimizes itself to make those apps run smoother.
Okay, now that's just cool. But I gotta ask, if chips can design and optimize themselves, what does that mean for, human chip designers? Are we all gonna be out of a job?
It's a valid question, but I don't think it's about replacement. It's more about like evolution. AI can handle the more routine parts of the design, the stuff that's repetitive and time consuming.
So it frees up the humans to focus on the big picture stuff.
Exactly. Setting the goals, ensuring safety, pushing the boundaries of what's possible, it becomes more of a collaboration, a partnership.
AI and humans working together to create the chips of the future.
That's the future I see.
Well, this has been an amazing journey. We started by talking about AlphaChip and its crazy chip layout skills, and now we're talking about self-evolving chips. It's like we've traveled through, like, the entire history of AI chip design in just a few minutes.
It's moving fast, that's for sure. And who knows what amazing things we'll see in the next few years.
One thing's for sure, it's going to be an exciting ride. Thanks for taking this deep dive with us, and be sure to join us next time as we explore another fascinating corner of the tech world.